Today we will study linear transformation. We'll take up a theorem. Theorem theorem is every every n dimensional vector space over the field F over the field F is isomorphic to Fn. So we'll prove this analysis of the theorem. Analysis says what? What it says that every n-dimensional vector space, if V is a n-dimensional vector space, n-dimensional vector space over F field F, that is VF, then this is isomorphic to F raised to power n. For example, if we take F is equal to R, then V of R is isomorphic to Rn, okay, n-dimensional space. So let us talk about the proof of this proof. Proof के लिए we are given Vn to be n-dimensional. So let V be an n-dimensional vector space, n-dimensional vector space over the field F. Now take since so since B is a finite dimensional vector space, finite dimensional vector space. This means that V as a basis, finite basis, say B, where B is equal to V1, V2, so on to Vn. Okay, so it is having n elements. Now let us define. Now Fn. Fn is nothing but F F F n times, and this is going to be set alpha 1, alpha 2, and so on, alpha n tuples. Say that each alpha I belongs to F for all I is equal to 1, 2, up to n. This is set. Now we have to show that to show V is isomorphic to Fn. Now to show this, to show V is isomorphic to Fn, we have to show that there exists a linear transformation. Sorry, we will talk about the isomorphism directly. There exists an isomorphism from V to Fn. So we will define this. So Define a map. Define a map T from V to Fn as follows. अभी हम लोग डिफाइन करेंगे मैप को. So we will take x in this domain. So let करते हैं x in V. Now this B is the basis of this V. So since since B is a basis is a vector space V, this means that x can be written as alpha 1 V1 plus alpha 2 V2 so on to alpha n Vn. Now we will define now T of x is equal to where alpha is belongs to f, I is equal to 1 to n. Now we define x, T of x is equal to alpha 1, alpha 2, alpha 3, and so on, alpha n. So we will define by this. This is what we have defined. So Tx is defined by if x is equal to this linear combination, we are just picking up. ये हम उठा लेंगे इसकी जो कांस्टेंट है इनको उठा के जो स्केलर्स हैं इनको उठाएंगे हम लोग और एक एन ट्यूपल बना देंगे. तो ये जो एन ट्यूपल है ये इसको डिफाइन करेगा इसमें. नाउ वी विल शो नाउ वी विल शो T is linear transformation 1 1 and 1 2. Let us show this. T is linear transformation. So we will take two elements now. Let x and y belongs to V because T is a map from V to Fn. So we are taking two elements here. Now x belongs to x or y belongs to V. X and y belongs to V. Now x and y belongs to B and B is equal to B1 से लेके Bn तक. ये इसका basis है. इसका basis है. So we can write x as a linear combination of elements of basis. So alpha 1 V1 plus alpha 2 V2 so on to alpha n Vn. Similarly, y can be written as beta 1 V1 plus beta 2 V2 and keep on doing this beta n Vn, where alpha is belongs to f and beta is belongs to f. I is equal to 1, 2, up to n. Now we will show that. Now let's check. Let A, B belongs to f, then ax plus by. This is going to be A alpha 1 B1 up to alpha n Bn plus B alpha 2 sorry beta 1 V1 up to beta n Vn, right? So we are putting like this A alpha 1 V1 so on to A alpha n Vn plus B beta 1 V1 and so on B beta n Vn. So we are getting this. So simplifying this, we will get this Ax plus By is equal to. So we will club them correspondingly. तो इनको सबको क्लब करेंगे तो ये आ जाएगा A of alpha 1 plus A of beta 1. This is V1 and so on. A of alpha n plus B of A of alpha n and this B of beta n. B of beta n. This is B of beta 1, and this is going to give this Vn. Now apply T of Ax plus By. Let us see what happens. Applying this, so these are all becoming the tuples. A alpha 1 plus B beta 1, comma, A alpha 2 plus B beta 2, comma, so on to A alpha n plus B beta n. Fine. This is what we are getting. Just breaking them up, break them. A A alpha 1, A alpha 2, so on to A alpha n plus B beta 1, B beta 2, so on, B beta n, and this is going to come as alpha 1, alpha 2, so on to alpha n plus B beta 1, beta 2, so on to beta n, and using the back definition is this of this is what? Alpha of x, B of T of y. So this is the back definition of this. This is the back definition. If this is alphas, this is going to be x. This is x is in terms of alphas. If y in terms of betas, so this is going to be betas here. So in terms of betas, we are writing y. In terms of alpha, we are writing x. So we have got T of ax plus by is equal to a T of x plus b T of y. So this is the criteria for linear transformation. This means that T is a linear map or linear transformation. Fine. So next we will show that T is 1, 1. T is 1, 1. So again we have to do the same thing. Now T is a map from V to F. So B is the basis of this. B, B is the basis of this. V. So we will take two elements. Let X, Y belongs to V. This means that X is equal to alpha 1 V1 because this is represented in terms of basis elements alpha n Vn, and Y is equal to beta 1 V1, so on to beta n Vn. So this is how we write this. Now, so that T of x is equal to T of y. So we have to show that x is equal to y. So putting the values, इसकी जो वैल्यू लिखेंगे T of x क्या होता है? This is equal to alpha 1 so on to alpha n. If x is equal to alpha 1 v1 so on to alpha n vn. ये इसके बराबर होता है. तो इसके कोफिशिएंट्स हमने उठा लेने हैं यहाँ से. Now this is going to come as alpha 1, alpha 2 so on to alpha n is equal to beta 1, beta 2 so on to beta n, right? Now this means that equating the corresponding alpha 1 is equal to beta 1, alpha 2 is equal to beta 2, alpha n is equal to beta n. Now, using these values, we can write that. This means that alpha 1 b1 plus alpha 2 beta 2 b2 so on to alpha n vn. This is equal to beta 1 b1 plus beta 2 b2 and so on beta n vn. And this is going to give you x is equal to y. So we have shown that taking tx is equal to ty, we have shown that x is equal to y. This means t is 1, 1. So t is 1, 1 here, t is 1, 1 and linear transformation. Now next we will show that t is on 2. T is onto. Now again, T is a map from V to Fn. Fine. So we will take here Y. So corresponding to Y, we will get X here. And then applying T, we will show that T of X is equal to Y. तो हम लोग इसको अप्लाई करेंगे. Now V क्या चीज है हमारे पास? Vector space. Vector space over F is a vector space over F, one thing. And इसका बेसिस क्या है हमारे पास? इसका बेसिस है, इसका बेसिस जो हमारे पास है, B is equal to V1, V2, so on to Vn. ये बेसिस. Now, taking Y in this, let Y is equal to alpha 1, alpha 2, so on to alpha n. Now, Tx की definition क्या रहती है? Tx की definition होती है alpha 1 से लेकर alpha n, where x is equal to alpha 1 V1, so on to alpha n Vn. ठीक है? ये रहेगा हमारे पास. Now, Y is equal to this है. Now, where alpha is belongs to F, choosing these alpha is, take x is equal to alpha 1 V1 plus alpha 2 V2, so on to alpha and Vn. So हम लोग ये कैसा एलिमेंट बनाएंगे? Now T of x is what? T of x is equal to alpha 1, alpha 2 by definition, alpha n, and this alpha n is nothing but is equal to y. So this is y. So we have shown that therefore for any y belongs to Fn, there exists x is equal to alpha 1 V1, so on to alpha n Vn, such that T of x is equal to y. So we have shown that corresponding to every element y here, there exists an x in V. So therefore, T is 1, 2. So we have shown that thus, therefore, T is linear 1, 1 and 1, 2. This means that T a is an isomorphism. Isomorphism. That is T from V to W, V to Fn is an isomorphism. This means that V is isomorphic to Fn. This is what we have to prove, that every vector space, every finite dimensional vector space over the field F is always isomorphic to Fn. So this completes the proof. This completes the